Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hi there, welcome to another great day here at the Big Bounce, Scotland's Festival of Physics. I'm Susan Morrison and I am your host for some amazing events today that we are holding live that you can join virtually here in the legendary, the iconic Barrowland Ballroom here in the East End of Glasgow. We're starting today with a world premiere, a kids show that's going to be absolutely fantastic. Get the kids round, we want them to ask questions on the screen, fire them into our presenters here at the Barrowland. Come and join us at the Big Bounce, get the questions in, and let's go and join Power Up.
Hi everyone, I'm Shaz.
And I'm Neil, and this is
Power Up! We are streaming live from the Barrowland Ballrooms, and we are so excited to be here today. Look at it! Look at it go!
So excited. Now, in case you're thinking that this is any green screen trickery, all right, look. Ta-da! We are actually here for real, in real life.
That's right, we've already gotten started on our demonstrations. So today we've got a really cool show ahead of us. So first of all, what's really important is if you have any questions throughout the show, then please do send them in, type away, and we'll answer them at the end. So, what is this show all about? Well, today we are going to be working as engineers and exploring different types of renewable energy.
Now, already you might be thinking, wait a minute, what is renewable energy? And don't worry, we will get to that. But first of all, we need to have a wee chat about our flat.
Our flat?
Yeah, well, you've been running up the electricity bill with all of that technology of yours.
What? Okay, I only have my phone and my telly and my Nintendo and my PlayStation and my washing machine and my fridge and my lights and my straighteners.
Yeah, and all the other stuff, and we don't have all day. Yeah, now all of that stuff uses up a lot of energy. Plus, what about how you get to the shops?
Oh, well, I do try to get the bus, but sometimes my pal takes me. She's got a cool, massive car.
Okay, I mean, it is a pretty cool car, yeah. But that also uses up a lot of energy and all of the fuel that it uses. Look, I added up all the stuff you use energy for, put it on our energy meter, and look, it's full.
Oh, okay, that is really full. But we all need these things.
That's true. We can't just stop using all of that stuff. But we need to remember that the energy for it doesn't just come from nowhere. Sometimes to get that energy, we need to burn oil and gas. Now, oil and gas are fossil fuels, and they're what we call non-renewable. And that means eventually they're just going to run out.
That's right. Now, fossil fuels are really not bad for our health or our environment. So today we're going to be exploring different types of renewable energy. And when we burn those fossil fuels, they release gases like carbon dioxide into the air. As I said, that's not very good for our health, so we need to find some solutions today, not be part of the problem.
That's right. And to do that, we're going to try and be engineers. Now, engineers are people that identify problems, then they design and test different solutions. They might make changes over and over again until they find something that works. Now, today our problem is that we want to get energy for all of the stuff we use in our everyday lives, but we don't want to burn fossil fuels to get it. So, in today's show, we have a challenge. We need to fill the energy meter for our flat while being kind to the environment. And that is where renewable energy comes in. Renewable means that it can be used over and over again. So unlike fossil fuels, it's not going to run out and it's not going to release all of that carbon dioxide.
That's right. So today, I couldn't bring all of my household things with me to test. Believe me, I did try. So instead, everything we power is going to be represented by an LED light. Now, it might look pretty small, and it absolutely is. Everything we're doing today is on a small scale. But this light could represent your tablet being powered, or your flat, or your city. We can use renewable energy to power all of these things.
So, the first type of renewable energy we're going to look at today is wind power. I imagine you're thinking, what is wind power? And believe it or not, It's power from wind. Very much a does what it says on the tin type of energy. Now, we can all know it's pretty blowy in Scotland, all right? But engineers have actually worked that to our advantage by making wind turbines that can use that to make electricity. Now, we can have wind turbines onshore, which means on land, or offshore, which means out at sea. So let's, out at sea, one in action.
Oh, Neil, no.
No? But I work for... No? Okay.
Okay.
Anyway, we'll move on for that one, because we have actually brought with us today a real-life wind turbine.
That's a real-life turbine. I always thought they'd be so much bigger than that, you know. Surely they're at least 3 times this size.
A bit more than that.
Oh, 4 times this size.
Okay, a lot more than that. Yeah, real ones are about 150 times this size. This one is just a model.
Okay, so does it work?
No, I haven't actually tested it yet. We probably should give it a shot. So, in a wee second, we are going to try and make this light come on using only power from wind. But for that to happen, we have a problem. In order for our turbine to work, there needs to be enough wind to spin these blades. So we're going to need something to create a lot of wind.
Is the light on, Neil?
No.
Oh, right, you meant use the fan.
But yeah.
Yeah,
the fan.
that would make
Thought
more
that might
sense,
work.
okay.
Okay, right. Let's get that set up. So, a proper source of wind now. And we'll just get this, making sure it's on. Right, are we ready?
I think so.
Watching the light in 3, 2, 1.
Oh. Is the light on?
No.
Oh. I have an idea. Ta-da!
Okay, nice. Bigger fan, more wind. Right. So let's give it a shot again. Remember, watching that light, see if it can go on. All right.
Okay.
In 3, 2, 1.
Is the light on?
No.
What? I don't understand. There must be something we're doing wrong. The blades are turned off.
Turned off? What?
Yeah, sometimes it can be too windy, and so we actually need to turn our turbines off. See how the blades are flat like that? But think about the blades on an airplane or under a boat. They're always at an angle, right? So, I reckon, if we turn these blades, this will let the wind push the blades around.
Okay, right. Let's give it a shot. So,
All right.
everything's in place. And remember, watching this light. Let's see. Okay, in 3, 2, 1.
Oh.
Okay, it's moving.
It is spinning. Is it spinning fast enough?
Oh, it doesn't look like it. Not yet.
Okay, we'll give it a moment.
Yeah.
The tension
It's definitely
is
getting
killing me.
faster.
Yeah.
Still getting faster. Oh, almost.
Almost there.
Almost. Can we see anything happening?
We're really building that tension, aren't we?
Exactly. Maybe we need a bit more wind.
Yeah, I think
Oh.
even more wind. Let's see.
Oh, I think I see something.
What
I
is
think
it?
it's the lights flashing.
Oh, amazing!
Awesome. I hope you guys can see that at home. We have actually managed to make the light come on just using wind power. Awesome. So, I suppose we need to have a wee think about how this turbine actually works.
Well, the wind will turn these blades, which then turns a number of gears inside the turbine. This then turns what we call a generator, and this is what creates electricity. Now, when we talk about energy, it comes in lots of different forms. You can have light energy and heat energy, but we'll come to those a little bit later on. Wind has lots of what we call kinetic energy, or moving energy. Now, when the wind spins the blades, that turns into mechanical energy. And when it goes through the generator, it changes to electrical energy.
Okay, so we've managed to take the energy from wind, and using our turbine, we've made electricity. So, I think we know what that means. We get to put wind power on our energy meter.
Amazing!
All right, let's pop that on.
Yay! Fantastic!
Stuff. All right, well, we've definitely made a start, but I don't think we're quite all the way there to getting all of the energy we need. We should probably look at a few different types of renewable energy.
Now I've got one, I think. On our planet, we get lots of light and heat energy from our sun. We call this solar energy. And there is so much of this solar energy. There's about 10,000 times more energy than all humans use.
That's loads. Okay, so surely we can use some of all that extra energy to power our homes.
Yeah, I reckon so. We just need the right engineering to collect it. And there's some great examples of this all over the world. In really hot, sunny countries, they use the sun to heat up bath water and cook their food.
But we're in Scotland. Yeah, so it's not a warm, sunny country.
Oh, no. But I think we can still use solar energy to make electricity. And for that, we don't need bright, direct sunlight, just enough daylight and a solar panel.
Hey, that looks like our flat. Oh, with a solar panel on top of it.
I know! So inside this solar panel are thin layers of specially engineered materials sandwiched between glass. Delicious. Now, when the light hits these materials, some of that light energy is turned into electrical energy. Engineers call this a photovoltaic panel. Photo meaning light, and voltaic meaning electricity.
Awesome. So that means we just need some normal light and one of these solar panels, then we can get electricity for, your Nintendo and cups of tea.
Yeah, definitely.
Amazing. Right, well, let's test it and see just how much electricity our solar panel can make.
This here is a multimeter. It'll measure the voltage, or essentially, it'll tell us how much electricity our solar panel is making. Now, it is pretty bright here in the Barrowland Ballroom. Oh, I feel so famous.
I know, right? Dream come true.
I know. So, let's take a reading.
Okay, so we'll pop our multimeter on. We can see, hopefully on our camera there, that it says 0.5 volts. Okay, is that any good?
Yeah, it's not bad, but I think we could get a bit more daylight on the go. Regular daylight.
Lovely, a classic desk daylight there. Good stuff. All right,
Classic.
let's have a look. So when we get that on,
Okay.
oh, it's changed. Oh, now it says 2.0 volts. Okay, that's better, right?
Absolutely. So more daylight means more electricity. Talking off, let's add a little bit more daylight.
Why not? We'll go the whole hog. All right, so we'll get that last one on. Oh, it's gone up again. Okay, so now it says 2.6 volts. Now what that tells us is we've made 2.6 volts of electricity. But what is 2.6 volts of electricity? Well, to give you an idea, your phone would charge from just 5 volts of electricity. So already, with our wee solar panel, we're about halfway to charging your phone. So, since we know we've made some electricity, how about we put it to some real use? We have disconnected our multimeter, and instead, we've connected the solar panel directly up to the flat. So, if we look at our lovely little window here, when we bring our daylight back on, we should see
My lamp's come
our
on.
lamp. Okay, now I'm going to get something to cover the solar panel just to prove to you that it really is from the solar panel. So when we cover it, we should see our lamp go off. We uncover it, and the lamp goes back on again.
Oh, amazing! I can't believe it. We've actually got a lamp to come on using solar energy. And that's great, because I was so sick of reading in the dark. It doesn't really make any sense. Why would I do that? Okay, that's so fab. Amazing. We've got our solar energy. So I'll just use this cell to power all of the flat. Show done. Sorted.
I mean, you know, if it was the real flat, I think we'd probably need a few more solar panels.
Oh, okay. How many more?
Right, wait a minute, get my calculator. So, I mean, if it's the real one, right, 2.4 volts is that, but then, you know, you've got your Nintendo, and then you've got to add on your straighteners, and then there's so many lights, and then you make like 8 million cups of tea a day, right? Yeah. So altogether, you know, that you're gonna need...
How many panels?
I mean, loads.
Okay.
Yeah.
That's useful.
Anyway, that doesn't matter, because remember, we are working on a small scale today. And that's fine, because if we were using solar panels to power a real flat, we would just use lots of little bits of solar panel connected up together into big ones to give us enough electricity.
Well, you might have guessed what is coming next. I think that means we can add solar energy to the energy meter.
Awesome! All right,
Go
on
do
it
it.
goes.
Yes!
Looking good.
Wow, 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 wow. Okay, so we have wind power and we have solar power. So I could power the flat all day, all night, and use all of the electricity. Yay.
Well, not quite.
What do you mean not quite?
Well, think about it. What if it's a lovely, calm day with no wind? Or, it's nighttime and there's no daylight?
So the wind turbine won't spin without any wind, and the solar panel won't work without any daylight.
Exactly. Yeah. How do we get our energy then?
Oh, how about we find some way of storing that energy? So we collect the energy from the wind power and from the solar power, we can store it and use it later on. Kind of like if you have a battery pack. You charge it at home using the electricity from your house, and then you take it out with you, and then use that to charge your phone later on.
Okay, sounds good. Now, I don't know much about batteries, but I do know another cool way of storing energy. You see, we can actually store energy in water using something called a hydroelectric dam. Now, for this next demonstration, we're going to have to use our imaginations. Like, really use our imaginations, okay? Because we're going on a lovely day trip up to the beautiful Loch Lomond, just north of Glasgow. So we know that Loch Lomond is a big body of water, splash, splash, surrounded by lovely tall mountains, which today might look suspiciously like a stool, but it is in fact a mountain. So this loch, surrounded by mountains, is the perfect place for our hydroelectric dam. Now, a dam is just a big human-built structure that holds back lots of water. In our hydroelectric dam, we have used some renewable energy to pump water from the loch up to behind the dam, where we've stored it for later.
This here is our turbine. When we need electricity, we'll release the water from the dam, and this will flow through the turbine. Water has lots of kinetic energy, the same as the wind. So when this water flows through the turbine will spin, changing that kinetic energy to mechanical energy. And then guess what? It's very similar to wind power. It has a generator as well, which will turn that mechanical energy into electrical energy. So when demand for electricity is high, like when you come home from school and put on the telly.
Oh yeah, after finishing all the homework.
Oh, yeah.
Love homework.
Oh, yeah.
It's important.
Definitely. Anyway, when demand for electricity is high, all we need to do at our hydroelectric dam is release the water. This will flow through the turbine, creating electricity.
Awesome! And we should be able to see, hope you can see this at home, that we have made our light come on again. Amazing stuff. Now, not only that, but the next time we have some extra renewable energy, maybe wind or solar power, we can again use that to pump water back up to the top and store the water there for later, effectively storing that renewable energy until we need to use it later to make more electricity.
Well, you know what that means? We can add hydroelectric power to our energy meter.
Awesome! All right, on it goes. Oh,
We're getting there. We're
we
so
are.
close.
We're so close, almost full. But you might be able to see there's still something missing. Now, remember at the start of our show, we talked about the fact that we also use lots of energy for our transport. Think about all of those cars, buses, and lorries on the road. A lot of them are using petrol or diesel, those fossil fuels, and that is releasing carbon dioxide into the air.
That's right. Now, that's not great for the environment or for our health. So for the last part of our show, we're going to be looking at some transport for the future. Now, you might be thinking we're going to look at electric cars, and they are pretty cool. But what we've got to show you, I think, is even cooler. Presenting our hydrogen car.
Here it is. So this is a car without a normal engine and without a battery instead, that runs on hydrogen. Now, hydrogen is a gas, the most common gas in the whole universe. And there's a lot of hydrogen here on planet Earth, but you won't find it as a gas. Instead, it's actually trapped in something else. It's trapped in H2O, or as you probably call it, water.
Water gets its name, H2O, because it's made up of 2 parts hydrogen, known as H, and 1 part oxygen, known as O.
So together, that gives us H2O. Now, before we can get our car to run, we are going to have to try and get some hydrogen out of the water. So, we'll get our camera lined up here. Brilliant. You should be able to see that we've got 2 tanks on the back of our hydrogen car, and they're filled up with water. We want you to watch those really, really closely as we try and make some hydrogen gas. Okay, so you might be able to see some bubbles forming in the 2 tanks. Now, this one over here is a bubble of oxygen gas, and this one, the one we really need, is a bubble of hydrogen gas.
Whoa. Is it ready yet?
No. Remember, it takes a few minutes. Yeah.
Oh, right, yeah. Okay, so we need to talk about the science first.
Okay, great. Yeah. We'll tell them about it in a wee minute, then show them.
Okay, great. So, getting the hydrogen out of the water is actually pretty complicated. You can't pick it out or use a sieve because it's bonded together with the oxygen. We need to break the water apart into separate gases using something called electrolysis. That's a big word, that one.
Very big word.
Very big word. Well, how does that even work? Earlier on, we left our solar panel out in the sun to charge up this battery pack you can see here. That means we're using entirely renewable energy to make this electrolysis happen. Now, the electricity will break the water into hydrogen and oxygen gas. Soon, our hydrogen gas tank will be full and our car will be ready to run.
Oh, exciting! Yeah. All right, so it's ready now.
No, it's not actually ready right now. You have to tell them about how the car's actually gonna run.
Oh yeah, do the bit where it's actually going to run. Okay.
Yeah, okay.
So how does the car actually run? Well, it runs on electricity. And in order to create that electricity, it actually has to join the hydrogen and oxygen back together again. So all of that happens inside this part here. I'm going to try and show you. So this blue bit here, this is called a fuel cell. And it's what a hydrogen-powered car has instead of a normal car engine. Now, unlike a normal car engine that might burn maybe petrol, and remember that would release carbon dioxide, our hydrogen fuel cell instead uses hydrogen, and it doesn't actually burn anything. Instead, inside this fuel cell, the hydrogen and the oxygen from these 2 tanks are combined together again. So they basically get mixed where they join back up into water. Now, what's great about this is when that water is made again, it also releases electricity. And then we can use that to power the car's motor.
So it is a bit like an electric car, except instead of a big battery, it uses a fuel cell and our hydrogen gas tank to create electricity. And the great thing about this is there's no carbon dioxide coming out of the exhaust, only water. And this technology is actually being used in Scotland. This year, the world's first hydrogen-powered double-decker buses are set to be launched in Aberdeen. We should plan a trip.
Oh, we should.
Definitely.
Yeah,
as soon as it's possible, of course. Now, our double-decker buses will have a fuel cell like this one here, and not one, but several hydrogen gas tanks on the roof. Amazing stuff.
So cool. So if it's such a great technology and a really clean source of energy for our transport, you're probably wondering why we're not all driving around Glasgow in our awesome hydrogen-powered cars already. And there are a few reasons. One of them being that it's still very expensive. Part of this fuel cell is made of something called platinum. That is a really, really expensive and really rare metal. In fact, it's even rarer than gold. So until engineers can work on making them a bit smaller and cheaper, they're probably still going to be in buses for a wee while.
Neil.
Yeah?
Guess what?
What?
It's ready.
What's ready?
The car's ready.
What car?
The hydrogen car.
Oh, the hydrogen car. Yeah, of course. It's been there a while. Forgotten. All right.
Okay, I'm going to take this out round the back for a spin, so I want you guys to follow me. All right.
Alrighty, so we're going to get our car set up over on the ballroom floor. Go for a little race. Now remember, while we're getting this set up, this car doesn't have an engine and it doesn't have a battery. We're actually making electricity on board using those two gases. All right, Shaz, are we ready?
I think so.
Awesome.
Okay, let's do a little bit of a countdown, seeing it's the end of the show.
I think we should.
If you want to, you can count down at home as well. From 3, 2,
Two,
1. Wow! Look at it go!
Oh, there it goes.
Oh, wow. Okay, we've got our LEDs to come on, and we've got a car to move. So I think that's a win-win situation.
Definitely, definitely. It looks so cool as well, doesn't it? I kind of wish I had one.
I know, it's kind of cute. Maybe all cars will look like this in the
Maybe,
future.
yeah, we might have a very futuristic car in a while looking like this.
It's running away from us.
It is, I know,
actually,
it's kind of
isn't it?
escaping a little bit,
Yeah, yeah.
But it is quite good. I don't want to get my foot in front of the camera and block it. It's going, you know what, it's coming back around.
Now remember, this is powered entirely by hydrogen, and so that is just absolutely cool.
It is, yeah. There's no harmful stuff coming out of the exhaust, only water. So a really, really clean form of energy for our transport. Awesome
Maybe
stuff.
buses will go a bit faster than this, though.
Hopefully buses will go a bit faster, although probably not in Glasgow if they're anything like the ones we already have.
No,
all right, we'll
fab.
switch our hydrogen car off before it runs out of fuel. And I think now that we've shown that we have made energy from hydrogen, it is time to put hydrogen on our energy meter.
I don't know if I'm ready.
Oh, well, you know what it means, because it means it's full!
We filled it! Oh my gosh, I can't actually believe it. We've managed to fill our energy meter using entirely renewable sources. That means we can power our flat using only renewable energy.
So cool. So now that we are coming towards the end of our show, let's have a little think about what we've been doing here today. Because right at the start, remember, we said we were being engineers. Because we identified a problem, we designed and tested loads of awesome, awesome solutions. We made little changes until we got them to work. We've managed to look at some amazing renewable energy sources. We've had a look at wind power,
Solar power,
hydroelectric power,
and hydrogen power. And these are just some of those possible solutions. There are so many more still to explore. There could be some we haven't even thought of yet. And Scotland is such a great place to be at the moment, with lots of our energy coming from renewable sources. Who knows? Maybe you could design the next type of renewable energy.
Exactly. Now, I think we are hearing that you guys have been putting some questions in the chat. Is that right?
First of all, big rounds of applause.
We'll clap ourselves.
You clap yourselves for power up, everybody. Fabulous work. Well done, well done, well done.
Thank you.
And you make me feel so old and stupid, but then that's
Always time to learn. Always time.
There's always time to learn. So just before we go any further, power up duo, just
Hello.
a quick question. We've got a question here that's been sent in. Thanks very much for that. But just a quick question. So does this mean that my next car, I'm going to have 2 large goldfish bowls on the back?
That is a very good question, and the short answer is no.
That's quite
You're
disappointing,
absolutely
actually.
fine.
I was looking
know.
forward to that.
Hoping it would look like that.
It's
you
lovely
could
and
put some
futuristic.
decorative ones on if you really wanted.
Yeah.
I could bling
So-
up my hydrogen.
You could.
Yeah.
Lovely.
So we will have a hydrogen gas tank and a fuel cell like this one here, but we won't need the 2 big tubes of water. We only really needed those to break the water apart and put it together again.
Right.
We were kind of doing both steps on this one car. Normally you would just go and fill up from a hydrogen station instead of a petrol station.
Okay. So do you think, I mean, this is a car which is zootering around, and a bus, there's a bus now.
Exactly.
Is there ever any time, do you think it could be something even larger than, say, what about an aircraft, an airplane?
Well, that would be fab, wouldn't it?
It would be really cool.
Yeah.
I-
Well,
I'm worried about the water coming out the back, though, because airplanes would be flying overhead just with water dropping on people.
that's a very good point. So the water that's coming out of the exhaust is actually what we call water vapor. So this is water in its smallest form, I
smallest
suppose
gas form.
you'd say. Yeah, in its gas form. Oh yeah, that would be the better way to describe it.
So I don't have to worry about any accidental aircraft leaks.
You're not going to have like
think so.
buckets of water,
Good.
randomly.
But do you think it's
splashing.
possible? An aircraft could do that?
Maybe. I'm not sure. I imagine people are probably looking into it.
I can see ships probably taking it up as a as a power source.
Yeah, absolutely. Yeah,
Then
they
they've got
have-
wind. They could have sails. couldn't they?
We could.
Exactly.
So-
We're kind of already using
And
it.
speaking of that, we've got a question that's come in from Callum in Edinburgh. Hello there. And Callum wants to know, is there a difference between onshore and offshore wind turbines? I mean, we're all used to seeing them onshore. We've seen one or two offshore ones. And he says, or is it just the location?
Yeah, again, short answer, basically yes. What we found when we were doing research for our show is that typically the offshore ones tend to be a little bit bigger on average. But other than that, they work the same. Obviously, the foundations and getting them out there is a little bit different. But they are just the same type of thing.
I think they're actually, and they're quite picturesque. I like them. I think
Yeah.
they're quite elegant.
I think
when they
so
go
too.
around.
Yeah,
I think so.
absolutely.
And if you ever stop your car and get out and go near them, you know, not too near. I don't want to have people rugby tackling me to the ground and thinking I'm some kind of anti-wind turbine activist. But if you get out and stand beside the road, the sound is almost soothing. The
Yeah,
whooshing sound
absolutely.
is really
Yeah.
quite nice. So now here's another question that's come in. I don't know where this is coming from. It says, are there any other types of renewable energy that you haven't mentioned?
Absolutely.
Fire away.
Yeah. Oh, great. No, I'm so glad that I've got a bit of a blank right
I
now.
know,
Fantastic.
Well, there are quite a few. There's
Yeah.
one I know of off the top of my head is something called geothermal energy. Another one of these big words. Now, thermal, you might recognize as meaning heat, and geo, from geography, meaning earth. Geothermal energy is getting heat and energy from the earth. And it comes in a few different forms. Some of it can just be digging up some pipe work, laying pipe and running water through that. The ground below us is actually at quite a steady temperature, normally warmer than even in the winter. So we can extract some heat from that. And in Iceland, they can actually dig down a wee bit further. And because they're in such a volcanic place, they're not that far away from lava, essentially. So they can use, yes, they can use...
So Iceland, you want me to run my house on lava?
Yeah, right? How cool is that? You
That
can
would
run your
be
house
so
on
cool.
lava power, yeah?
Also, I think that's a great tagline for Iceland. Iceland, never too far away from lava.
Lava. Did you ever play that game when you were kids? Like the floor's turned into lava.
Yes,
so you
only
could really
as a
do it in the
kid.
living room. Like, we're
Yes.
keeping the house warm.
We
'cause the
definitely don't
floor's
still
turned
do that in lockdown, you know, with all the spare time.
Yes, this is pipe in the lava. It will keep the place nice and warm, but you'll need to stay on the couch.
Yeah, exactly.
So we've got geothermal, and what other? Have we got any other forms that you haven't discussed?
We've got other ones involving water.
I've seen
but-
ideas involving burning waste. Is that a possibility?
Yes, absolutely. So you can create biofuels. So that is burning waste, as you're saying, just normal everyday waste, and creating electricity from that, or creating fuel from that. So I think there are some examples of waste-fueled buses. God, we love a bus, don't we?
Just love a
We
bus.
love a
Love a
fueled bus. And that is using waste to power it. There's a bit of discussion still about the sustainability side of it, like how good for the environment it is on a whole to make and then use.
Now, I have seen an idea of landfill sites producing gas, and that's being. Is that something that you've heard? Because apparently that's a possibility.
Yeah, you're right.
No, we're not having this, Neil. Because basically, I have contributed to landfill sites. So that's all my old Jackie annuals from 1975, slowly turning the wheels of industry. But then again, it's for a good cause, I suppose.
Exactly,
But
yeah.
apparently, so that can be used. That's almost like geothermal, isn't it? Bringing the gases out.
It's actually quite different. It's a wee bit more similar to what Shaz was saying about getting energy from waste and producing gases. So when we throw stuff into landfill, if there's any food waste in there, it starts to all decompose and rot away, and that releases methane. Yeah, so we can look at it as a good thing because there's already a lot of stuff in landfill, and it is just producing that gas, which is now methane is a type of gas that we can burn and get energy from. So yeah, it's more of kind of using something that at the moment is a problem, but we can tweak that a little bit and use it, turn it into a bit of a solution.
Yeah,
Methane.
methane, you've heard that one before.
Yes.
Yeah. I thought methane was a big problem because cows were producing methane and it was destroying the ozone layer. So are you suggesting that we somehow attach cows
Balloons?
to...
No.
I'm not sure how
Some sort of mechanism to collect the methane from the cows.
If you're watching at home and you can think about a way of attaching cows from the methane production area to a power plant, I think maybe you could walk about with a cow Think about
Everyone
it.
gets a cow.
Everyone gets a cow. How would you like- a methane-producing cow. Oh, and then you could power your mobile phone from your methane-producing cow. Obviously, you're not going to get that on a bus.
Get your designs in as
Get
soon
your
as
designs in
possible.
as quickly as possible, please. I'm not putting a cow in the back of my car just to fuel my car. Right now, here's a sensible question from a sensible child, not from me. If I can't afford my own wind turbine or hydrogen car, how can I use renewables on a daily basis? I mean, can we just forget the cow idea? Okay. So
We'll move on from that. Yeah.
Well, what you get is a bull that also produces meat. No.
So how can we
could you
use
use it in a
renewable
daily-
energy? Well, you probably already are. Yeah, I mean, none of us bought our own wind turbines, but there are loads of wind turbines across Scotland producing electricity. And it's not just for the homes around it. That electricity gets shared around the whole country. So we're all already using renewable energy.
So it's all contributing at one bit. Is there going to ever be a time when renewables take over from fossil fuels to produce enough energy for the country? Yeah.
Well, that's what we're kind of hoping for. Yeah. A major problem is, or a bit of a problem is about in the storage and being able to make sure that when we do have higher demand for electricity, that we have enough renewable energy to then send through to all of the houses. Yeah, that's basically.
Yeah,
the
and we're close to that point in Scotland. Not
close to that
globally,
point.
but there's a lot of renewable energy made in Scotland. In fact, I think just in the last year, we've had the least amount of coal used for power that's ever happened in Scotland. So there's been some really, really awesome milestones of renewable energy over the past few years.
That is extraordinary. Absolutely brilliant. Thank you. Power Up team. You've given us a glowing light into the future and a renewed interest in cows, which I didn't really expect. Don't forget,
did that
if you've got a drawing there about how you think a cow can help to produce renewable energy that we can use in our daily lives, you send that drawing in because we want to know.
Amazing. We look forward to that
look forward
very
to that.
much. Very
We
much.
look for Scotland
Amazing.
can use all the help it can get. We've got a bright future there. But so thank you very much from the Power Up team. Thank you.
Thank
Thanks
you.
for having us.
Thanks, everybody.
Thanks, everyone. Bye-bye-bye.
Now, off, scoot, and
Oh,
come
should
up
we
with
give it
clever
another little-
ideas.
Oh,
for the
sorry.
Take it.
Oh,
Look at that little car. That's so cute. And that was the Power Up team there. We are in the legendary Barrowland Ballroom. Take a look at this, isn't it? It's amazing. And join us later on this afternoon when we'll be looking at climate change, which is serious, but it's also simple and amazingly solvable. So join us at 2:30 this afternoon where James will be taking us through his look at climate change and how we can do something about it. And we're also looking for your questions on that, so don't forget, if you're tuning in this afternoon, get your questions in on the chat board. Incidentally, we'd like to see your feedback as well. If you just go down on the bottom of the screen, there's a feedback form. You fill that in and you go into a free prize draw. And if you win the free prize draw, you win, yes you could win a Lego model of the Barrowland Ballroom. I mean, who doesn't want that? Who doesn't want that? So get onto that feedback form, let us know. So that's it from us here right now for the Power Up team. But we're back this afternoon, not only with climate change, but the cabaret of dangerous ideas later on this afternoon. So that's us for just now. I'm Susan Morrison, and I hope to see you again later on this afternoon here at the Big Bounce. Thanks.